Okay, hey guys, welcome to chapter 2 Kinematics. Today's video we are just going to talk about the first three items A, B, and C, which is the difference between distance and displacement, difference between speed and velocity, and what acceleration is. Okay, so let's start off with distance and displacement. We are right now at page 20 of your textbook. To turn to this page, feel free to pause the video anytime to take some notes. Okay, scalars and vectors. What are scalars and vectors? Scalars are basically physical quantities with a magnitude, and vectors are physical quantities with both magnitude and direction. Okay, here are some examples of scalars and vectors. Okay, we've mentioned this in the class. An example, looking at the example of distance and displacement. Basically, the distance between to move from A to B, you can actually go via the green route or the blue route. Okay, so the distance can be 10 kilometers or 7 kilometers, while the total displacement is basically the red route, which is not exactly a route but is a distance measured in a straight line in a specified direction. So basically displacement, you simply just connect the 2 points with a straight line, the start and the final point, and measure the distance between these 2 points. So in short, the blue and green lines represent the total length covered by a moving object, which is the distance, and the red dotted line is not really a path, but is the displacement, which is mainly the distance measured in a specified direction, which is from the start to the end. Okay, so distance it travels is either 14 kilometers or 20 kilometers, and if I move from A to B and back to A again, like what this second part actually says, the distance covered you just multiply by 2. For example, the green path will be 10 times 2, because I move from A all the way to B and then back all the way to A again, which gives me 20 kilometers for the green path. For the blue path, it will be 7 plus another 7, which is 14 kilometers. Okay, so that's the distance from A to B back to A again. And the displacement, since the original starting point is at A and the final point going to B and back to A again is also at A, the total displacement is 0. Okay, got that? Alright. Okay, you can look through this example yourself, like what we went through in class. Okay, next we're going to talk a little bit about the difference between speed and velocity. Okay, so speed, the definition of speed is the distance moved per unit time. We are right now at page 21. Do underline these key points. The SI unit for speed, I think you're probably familiar with this already, is meters per second. The textbook actually uses this notation, meters second minus 1, but we try to I actually prefer meters slash second, so that this is more what we actually use, what you are more familiar with, and what we actually see in real life as well. Okay, try not to use the meters second minus 1, because you may tend to, if you put a slash there with a s minus 1, the whole thing will be wrong. So just try to stick to this convention so you won't go wrong. Meters per second. Okay, that's for speed. It's the distance moved per unit time. Okay, so average speed is mainly just the total distance traveled divided by total time. Do highlight this. Okay, we gave you example in the class for the distance traveled for a car. Okay, over here in the textbook they have the distance traveled, total distance traveled during a 100 meters race for the 2008 Beijing Olympics. You can see that the total time taken was 9.69 seconds for Usain Bolt in the 100 meters, and that was the record at that time. So the speed, average speed, we just use the total distance divided by total time. The average speed for Usain Bolt in the 100-meter event was 10.3 meters per second. Okay, that doesn't mean that he travels at 10.3 meters per second every second. He probably started off a little bit slower and accelerated. He was got a bit faster and was fastest towards the end. So average speed 10.3 meters per second. Okay, now we're at page 23. So what is velocity? Velocity is the rate of change of displacement. Okay, just so that we can see the difference between speed and velocity, I would just like to rephrase this definition over here. Do copy this. Velocity is the change of displacement per unit time. Over previously we saw speed was a change of distance. Right now velocity is the change of displacement per unit time. Okay, basically the same, means the same thing. The only difference is that one we are looking at distance, the other one we are looking at displacement. So direction is important. SI unit basically the same, and we're looking at average velocity over here. Average velocity equals total displacement over total time taken. Okay, later we're going to watch a video about the difference between these two cases. Okay, so you can read through this example. Okay, finally we talk about acceleration. What is acceleration? Okay, we covered a little bit of this in Sec 1. Just to recap, an acceleration, it simply is accelerating when a velocity changes. So over here at page 24, do highlight these words here. Accelerating, an object is accelerating when its velocity changes. So in other words, the object undergoes acceleration when it's either its speed or direction change. Okay, so over here you can see most of the time over here in our syllabus we are talking about increase or decrease, the change in speed only. Okay, change in direction is not so much covered, but we actually just to take note of that here, because that's the actual definition. So it can either be a change in speed or a change in direction or change in both. Okay, but for the purpose of the N and even the O level syllabus, we are mainly just looking at the change in speed. Okay, so the official definition for acceleration, okay, just highlight this. Acceleration is the rate of change of velocity. Or to rephrase it again, okay, do copy this down. Acceleration is the change of velocity per unit time. Okay, so if we look at, if there's a formula, it will be the change in velocity divided by time taken. Okay, explained in class. The units that we use is SI unit for acceleration is meters per second square. Okay, do write this down. Again, I'm not really comfortable about this notation ms minus 2, so try to use this so it can be a little bit more familiar to you. So meters per second square simply means meters per second per second. Okay, so we can have uniform acceleration. Uniform acceleration means the change in its velocity is always the same per unit time. Okay, so for example over here, when an object at 1 second, the object is 20 meters per second. 2 seconds, the object is at 40 meters per second. 3 seconds is 60 meters per second, and so on. So you can see the increase in velocity. Okay, do circle this. You can see the part that is uniform or constant is the change. That means every time it is adding 20 over here. Can you see that? Okay, so similarly goes to it if it's slowing down, 80 to 60 to 40 to 20 to 0, and it's not moving. Okay, you can see every time the velocity is actually decreasing by 20 meters per second. So uniform acceleration is constant rate of change of velocity. Okay, to highlight this at page 24. Okay, the last part for this video, we'll just finish off with the formula for acceleration. This is a little bit too wordy. I think we are more familiar with this formula here. There are basically just 4 variables, or to be more specific, 3 variables for the formula for acceleration. Okay, acceleration basically just equals to v minus u divided by, this triangle simply means change in t. Okay, what is v? V is just the final velocity. U is the initial velocity. So always remember it's final minus initial. Okay, how we use v and u are simply just symbols to denote the final and initial. Okay, why v is final? Because v comes after u, correct? Okay, so what about change in t? Okay, change in t is simply over here the time interval between tu and tv, so it's the total time taken. Okay, one example here will actually serve to explain this formula better. So you can see a car at rest travels in a straight path. Oh, by the way, do highlight this part over here that I actually asked you. I would just replace this formula with this simpler formula over here. Okay, so a car at rest starts to travel in a straight path, reaches a velocity of 12 meters per second in 4 seconds. What is the acceleration, assuming uniform acceleration? Okay, so we assign the direction to the right as positive, given these are what is given. Okay, how do I know the initial velocity is 0? So this is how we got to know that. Okay, because a car at rest means initial velocity is 0. Okay, final velocity 12 meters per second. How do I know that? Over here, right? Okay, what's the total time taken? So total time taken is simply just 4 seconds, and the acceleration is basically just v minus u divided by 4. It gives me 3 meters per second square. Okay, can look at yet another formula of a golf ball. So I have u and v because this is initial, this is final, so basically it slows down 10 seconds. So basically just v minus u divided by 10. Oh, and you notice the value of a over here is negative. Every time we get a negative, it means the velocity is slowing down or is decelerating. Okay, so just highlight this part here. All right. Okay, so that's basically for uniform acceleration. What is non-uniform acceleration? So non-uniform acceleration simply means an object increases its or decreases its velocity. You see over here, increase, then it decreases. See, the change is not constant. Basically, that's all it means. All right. Okay, I hope you enjoyed this video as much as I enjoyed trying to do this. Okay, next I'll be showing you a short video to explain the difference, like what I mentioned about the differences between speed, velocity, displacement, and distance. Okay, all right. So hope you enjoyed the video, and happy revising. Cheers.